Alright, so in this video we're going to talk about modified box plots as opposed to regular box plots and how to definitively identify outliers. So, of course, outliers are important to consider. They can impact your statistics a lot, especially, of course, means and standard deviations. And so we want to determine, well, what exactly makes an outlier? Now remember, this is a little bit different from unusual data points. Unusual means we're going to look for points that are more than 2 standard deviations away from the mean. Outliers, in this case, has a specific formula to calculate, and it's basically any point, any data value that is more than 1.5 times interquartile range. Oops. There we go, highlighter. 1.5 times interquartile range above or below Q3 or Q1. All right, so to give you a little bit better idea of that, we're going to sketch up a rough box plot. So you imagine you have, we're going to draw our little box plot here. We've got our interquartile range, and I'm just going to, let's say, so we're going to take this distance, this interquartile range, remember this is the IQR. We're going to make it 50% bigger, and we're going to mark that above the quartile 3. So anything up to that point would not be an outlier. So this is Q3 plus 1.5 times interquartile range. And then we're going to do the same thing. We're going to take that interquartile range, grow it by about 50%, and go about the same distance down. And so this is going to be Q1 minus 1.5 times interquartile range. So these are what are called fences. Okay? And so basically anything outside these fences on either side, right? Those are outliers. Write that in red. So if you have a data point that falls further away from the quartiles than this distance, it's considered an outlier. So anything in the middle is going to be not an outlier. Okay? So then once we've identified these fences, we draw our whiskers out to the highest and lowest values that are not outliers. So I'm going to label fence and fence right there. Okay? So let's do an example. We have our tornado deaths again. So this is the deaths each year from tornadoes in the US from 1990 to 2000. And in an earlier example, we had found the 5-number summary as 25, 30, no, 33, sorry. Let's see, 39. Wait, I'm going to go double check these. So we had 25 for our min, sorry about that. 33 for Q1, 40 for our median, that was the number in the middle with 5 on each side. 69 for Q3, and 160 for our max, right? And so here we have our interquartile range, which is our Q3 minus our Q1, remember. So we've got 69 minus 33, which is equal to 36. And then we're going to grow that by 1.5. So we're going to make it 50% bigger. So we're looking at 1.5 times 36, which is going to be 54. All right. So now we calculate our fences. So we say, okay, well, I'm going to do Q3 plus 1.5 times interquartile range. Anything above that is going to be an outlier. So we're looking at 69 plus 54. Right? So what is that going to be? That is going to be 123. And then on the low side, Q1 minus 1.5 times interquartile range. So we're looking at 33 minus 54, right? Which is negative 19. Okay, and we're going to go ahead and make our sketch here, right? So we have, we're down, we got to do 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, right? Okay, and so we know from our fence here on the lower side, our fence is negative 19, which is well below our lowest data value. So 25 is not an outlier. So we're going to draw our whisker to there. We've got our Q1, which is 33. That's about here. Our median, which was 40. Our Q3, which was 69. That's about here. And now we have determined our fence goes up to 123. So 130 is actually going to be an outlier, right? 130 is going to be an outlier, while 94, so 130 is going to be an outlier, and 94 is going to be not an outlier because it's inside the fence, right? So we're going to draw our upper whisker up to about 94. Now my box plot is in two different colors. And we're going to put a dot at 130, right? Because it's an outlier. Okay, oops, go back. So we've determined from our fences 130 is an outlier because it is outside our fences. It is above the upper fence of 123, and that there are no lower outliers. All right, so let's try one more example in this video. We have, this one's about baseball. So in 1961, Roger Maris hit 61 home runs. That was a big deal back then. And so he played for 10 seasons in the American League, and we have the number of home runs that he hit in each of those 10 seasons. So what we want to know is that year where he hit 61 home runs an outlier or not? All right, so we have 10 data values here. And so first off, we need to find our median. And so our median is in place 10 plus 1 over 2, which is 5.5, which means that it's going to be right here in between 23 and 26. Now, we don't really care right now what exactly the median is. What we do care about is finding the interquartile range because we were asked to determine if there were any outliers. So we need to find Q1, right? So we have 5 data values here. Right, and of course we don't need to do a calculation there. Hopefully you can see that 14 is the number in the middle here. So this is our Q1. And then same story over here, 33 is our Q3, right? So we have an interquartile range then, Q3 minus Q1, 33 minus 14, which is 19. We're going to make that 50% bigger, so we're going to multiply it by 1.5. So 1.5 times 19 is going to give me 28.5. All right, so remember this interquartile range here is the distance from quartile 1 to quartile 3, from the 25% mark to the 75% mark. So this is saying that our middle 50% of the data spans 19 home runs. Okay, so we need to calculate our fences. I'm going to change colors for the heck of it. All right. So we've got our fences, right? We're going to calculate lower fence just for the heck of it. Q1 minus 1.5 times interquartile range. So we've got 14 minus 25.5, which is negative 14.5. So there are no low outliers. So in other words, there are no outliers on the low side. Then we're going to do the other side. We're going to do our Q3 plus our 1.5 times interquartile range. So we've got 33 plus 28.5. And when we add that, we're going to get 61.5. So guess what? That year where he hit 61 home runs, actually not an outlier. So no high outliers either. Although it's a really close thing, if he had hit one more outlier, it would have been, if he had hit, oh my gosh, if he had hit one more home run, it would have been an outlier. So if this had been 62, it would have been an outlier, but instead it just barely misses it. All right, so thank you. That's it for this video.